Hi, everybody. My name is Vahid, and I would like to solve some Leetcode questions with you. The Leetcode question that I have chosen for today's quick session is questions 141 and 142. And these are about linked list cycle, how sometimes you might have a linked list cycle within uh, a linked list. So it's important to be able to detect them, and this is what these questions are asking us. Now, regarding the first one, basically what it's asking is it's saying the given head, which is the head of your linked list, determine if the linked list has a cycle in it. And the cycle happens where one of the nodes, like the node which is supposed to be the end node of a linked list, is actually pointing to another node within that linked list. And here we have the definition of the linked list. It contains a value, and it also has a link to the next element of the list node in the linked list. So for the very first and easy question, it's just simply going to ask us to check whether that cycle exists or not, and return true if the cycle in the linked list, or otherwise return false. Well, here we have an example here. We have four nodes with these values, 3, 2, 0, and -4, and position 1 denotes to the location where it's basically the index of the list node that actually the loop goes back to it. So basically, if we start traversing, one important thing to keep in mind is if we start traversing this linked list, we will eventually return to this node in here. Here we have another example, 1 and 2, and the position is 0. So we have a loop to the first element of the linked list with index 0. So we have a cycle in the linked list, and the tail connects to the 0th node. All right, I haven't worked with Kotlin in a while, so that's why I would like to um, use the IntelliJ IDE for this purpose. So I'm gonna actually use Kotlin for this case, and we're gonna call it solution for 141. And let me clean this code, and let's have a function here. All looks good. We do have actually a list node here that I defined earlier based on the list node definition of the that we have here. So that we can actually test it. Now, right off the bat, an easy solution that comes to mind for regarding this question is to have some sort of a data structure which keeps track of all the nodes that we visit and see whether we are visiting that node again. So because of this approach, we need to use hash sets or hash maps. We really Well, for hash maps, we can use them if we want to somehow use some sort of a key. But in this case, we do not really need to use a key, so we can just use a hash set. So let's do that then. Let's create a set. Let's call it node set. Actually visited node set, so the name is actually meaningful. And I'm gonna use a mutable set of list node. And that's it. Now, we want to iterate towards all this list node. So we have to start with the head. Well, the head is not null. And actually, we want to check if the set already contains that element in the set set or not. So we're going to use the contains method, and we do this. So it should not contain it, basically. So as long as it's not null and it does not contain that head, you want to add it, add the head, and then you want to go to the next element. So this is Kotlin, and by default, input parameters are final. So I'm going to define new one. So age, age, age year, and age year. Awesome. If you reach, so we have to determine whether we should return true or false in here. If age at this point is null, actually let's do it Kotlin style. So if it's not null, we actually do have a loop. Otherwise, we don't. And why is that? Because if we are traversing and we have not reached the very end of the linked list, that means that it actually is that node is currently contained in the set. So there's already a loop. So that's why we're going to return true. But if we just traverse the whole linked list here normally and we reach the end and there's no duplicate and none of the visited nodes are already contained within the set, so that means that there's no loop and we're going to return false. Let's try. To create the example would be a little bit complicated. So let me try this actually on the Leetcode website actually. So let's run this. So it's all good. It actually has worked as expected and things look good. So let's try to submit this. Awesome. That was a relatively easy approach. We made use of hash sets, and the fact that checking whether that element already is in the set is an operation of O of n. The downside with this solution though would be the memory. So as you can see in the worst case scenario, we're gonna make use of a memory of O of n because we are keeping a record of all the elements that are visited within this hash set. So worst case scenario, that would be n element. And that's why if you look at the follow up in here, it's asking us to see if we can solve it in constant memory. So that's the next thing that I think I would like to tackle in here. So let's get back to our IDE. So we have implemented the disassemble, but now I don't want to actually use a hash set for it. So because of this, I'm gonna show you briefly here. Let me minimize this and bring this up. So we have, for example, any of these. Let's say we are at 3, 2, 0, -4, and -4 is pointing to the second element with index of 1. There are different ways to approach this. Another very easy and straightforward approach, if you want to do it in memory, with like O of 1 memory, is to actually make note of all the visited list nodes, but by changing their values. So a node value could be something between -10 to the power of 5 and 10 to the power of 5. What we can do is we can use like the minimum integer. I think in Java it's like something like integer minimum. Okay? So basically we would know if we have visited. So by changing the value of every node that we visit, we can know if the loop has a let's take a look at this example here. Another way that we can check this is we can just traverse we have a loop here. So by changing the value of these nodes, we can know if we have visited them before or not. So we once we reach the last element, I mean technically it's not the last element because we have a loop. We go back to the element index 1, and here is where we realize that we've already visited this node. So by reaching this node, we will return true, and we will let the compiler know that yeah, we have reached there actually exists a loop in this question. So to solve this, I'm gonna call it number 2. I'm not gonna be using this, and while the val, sorry, so val is not equal to integer max value. So we need to make sure that the max value, for example, is above the range of the question here. So sorry. So with that, we have to check the range of the numbers for the value. So they're between minus 10 to the power of 5 and 10 to the power of 5. So technically, we can have something outside of this range, and that will work. Okay. So don't need this, and I'm gonna change this to h.val is equal to integer max value. And this should also work in So let's try this. Oh, it should be called has cycle. Okay, let's try this. Awesome. So we managed to submit this one, and it actually has worked pretty good. Like if you compare the runtime and the memory consumption, this one's quite better. And in terms of the number of submissions that it beats, it's doing pretty good. So this is for the scenarios where we want to do this in place. Now, this is another variant of this question, and it's a little bit more difficult. And if I remember correctly, the difference here was that they were asking you to return the node where the cycle actually exists. Yeah. So in this case, which is very similar to the example that we had in the previous question, 141, you should return 2. So that would be index 1. So we can use the same our first submission for the question, and that's with memory of O of n. But if you want to do it in constant memory, we need to think about this because we cannot just change the value of the nodes as we visit them. Because if we change the value of the node, then it wouldn't be exactly the node that we visited. And we can try that. We can copy the solution that we submitted here, and we can submit it here. Actually, we should call it text cycle. The difference here would be that we return edge. Otherwise, we're going to return. No, it would be edge in any case. I think, yeah. Oh, interestingly, it has accepted our solution. We can try to submit it. So that's something they need to fix in Leetcode's assessment, which interesting this worked. But this is not exactly what the question is asking. So the question is asking us to actually return it, and let's say we don't want to like change the value. So this would make it a little bit more complicated. But thank you very much for being with me and watching this, and I'll see you in the next video. Take care.